Hello everyone, welcome to this video. In this video, we'll be learning about multiplication of cycles whenever we are having permutation groups with us. So suppose we have a cycle 4, 6. So that means 4 here is going to 6 and 6 here is going back to 4 and all the other elements, they are kept fixed here, right? So representing this thing in terms of array, we have all the elements 1, 2, 3, 4, 5, 6 represented as 1 going to 1, 2 going to 2, 3 going to 3 and 5 going to 5. They are all kept fixed, whereas the element 4 is going to 6 and 6 is going back to 4, right? So we may express a cycle like this in the form of array like this, where the symbols which do not appear in the cycle, they are kept fixed. So you know how we can interchangeably use the cycle and the array notation. Okay, now we already know how to multiply these arrays, how to multiply these two arrays. Suppose we have one array and we have second array. So we start from right to left like this, and then we go from in the rightmost permutation. That means in this one we select a number, we see what is just below this number corresponding to this number. Here we'll see what number is the same number. We identify this same number here in the left permutation, right? We see what is directly below it. So we have this as the answer to this permutation, right? So this is how we multiply two permutations. Now in our case, now we are interested to calculate how do we multiply cycles. So for that, we can directly multiply cycles. So let me explain this thing to you in the form of this illustration. So we have alpha as this and beta as this, as two cycles. So here 1 is going to 3 and 3 is going to 1, 2 is going to 7, 7 is going to 2, 4 is going to 5, 5 is going to 6 and 6 is coming back to 4, 8 is going back to 8 itself, right? For alpha. For beta we have 1 going to 2, 2 going to 3, 3 going to 7 and 7 coming back to 1, 6 going to 4, 4 going to 8, 8 coming back to 6 and 5 is coming back to 5 only, right? So this is how we define alpha and beta. Now you can notice here that we have the number 8 written as one cycle and the number 5 written as one cycle. So in most of the time in cycle notations, just for convenience, what we do, we just remove these one cycles. So that means when someone look at a permutation of this kind 1, 3, 2, 7, 4, 5, 6. So that means the number which is missing here, the number 8 is missing here. So we treat them as one cycle, right? So we assume that the missing numbers, they are one cycle. So that is what I have written here in cycle in cycle notation. Sometimes one cycles are not written and they are omitted. Thus, whenever a number in the cycle notation is missing, we consider a one cycle of that number, right? A missing number is treated as a one cycle. So you should keep this thing in mind whenever you solve such kind of cycle permutations in cycle notation. So now we are interested to calculate alpha multiplied with beta. So what is the value when we do the calculation directly in terms of alpha and beta? So when we wanted to calculate alpha and beta, we just have to copy down the contents of alpha and the contents of beta here, right? After doing so, what we will be doing here, so we start with some element from beta. Again, we'll be moving from right to left, right? So we write alpha in the manner here and beta, it is coming afterwards. So we are writing it afterwards only. So from here we may select one number. So suppose we are selecting the number 1. So we are writing number 1 here. So now we have to move this number 1 from right to the left position, right? So how we may do that? We have to look that what happens to 1 when we cross this permutation beta. So when we cross this permutation beta, 1 moves to 2. So that is what I have written, 1 moves to 2, right? So that means our answer is now 2 because we have applied the permutation beta onto the number 1, right? So now we'll be looking at 2 in this permutation. So 2 for 2 here, 2 maps to 7 under this permutation alpha. So 2 goes to 7. So that means 7 is our answer. So overall what is happening when you are multiplying this alpha with beta, so we are seeing that 1 moves to the number 7. So that means we'll be next seeing what to what number will 7 move. So for that we start with 7, see what happens to 7 under beta. 7 goes to 1 under beta, so that is what I have written here. Now we'll be seeing what happens to 1 under alpha. So 1 goes to 3 under alpha, so that is what I have written. So 3 is the answer. So that means your 7 would now go on to 3. So the next number is 3. So we have 1 goes to 7 and 7 goes to 3, right? Next we'll be looking at to what number does 3 move to. So let's see, we start with 3 and we'll see to what number does 3 move to. So let's see, we have 3 here, right? For 3 under beta it moves to 7, so we have 3 going to 7. Then for 7 under alpha we have 7 going to 2, so we have 7 going to 2, so 2 is the answer in this case. So we have the next number as 2. Now we are interested to see 2 moves to which number, because our cycle is not yet complete. So we'll be writing 2 here. We'll be looking what will be 2 under the permutation beta. So you see 2 goes to 3 under beta, so 2 goes to 3. Next we'll be seeing what 3 goes to under alpha. So 3 goes to 1 under alpha, right? So 3 goes to 1, so that means 1 is the answer. So 2 moves to 1, finally 2 moves to 1, and 1 is actually the same thing. You can write 2 moves to 1. So this completes our cycle. So therefore in this case we have one cycle as 1 going to 7. Why this is so? Because you can see we have 1 that is moving to 7 when we apply alpha and beta to it. Then 7 goes to 3, then this 3 goes to 2, then this 2 goes to 1, right? And 1 is the number from where we have started. So we have completed our cycle, right? So we can write the cycle as 1 7 3 2. Right? So this is a 4 cycle. You obtain 1 cycle for alpha beta. Now we have to see for the remaining numbers. So we have 1 within our cycle, 2 within our cycle, 3 within our cycle. Let's move for the next number, which is 4. For the next cycle we do the same method. We write alpha here, we write beta here, and then we start with the numbers which has not yet been taken. So let's start with 4. Let's see what happens to 4 when it is moved through beta. So when we shift this 4 towards this beta, you see 4 goes to 8. So we have 8 as the answer now. Next we'll be seeing what happens to 8 when it moves from alpha. So 8 goes to 8 only. So we have 8 here. So 8 is the answer. Next we are interested to see what happens to this 8. So let's write it here. When you move from beta, this 8 moves to 6. Right? So 8 goes to 6. And what happens to 6 under alpha? This 6 goes to 4. So your final answer is 4. Now you see you started with 4, you reach at 4, so this completes one cycle. So therefore we have 4 going to 8 and 8 going to 4, so this completes our cycle. So this forms a cycle 4 8. Now this is a 2 cycle, so therefore it is known as a transposition. Next for the last element, so now we have the elements 1 2 3 4 covered with us. We are left with the elements 5 and 6. So we may start with 5. We may start with the element 5. So let's start with 5. Now we'll be looking at this 5 under the permutation beta. What happens to 5 under beta? 5 goes to 5 only, right? So we have 5 goes to 5. Next we'll be looking at what happens to 5 under alpha. 5 goes to 6, right? So 6 is the answer. Next we'll be looking at the number 6. What happens to 6 under beta? So when you move under beta, 6 goes to 4. So what will happen to this 4 now? Under alpha, this 4 moves to 5. So we have 4 moves to 5. So 5 is the answer. So you see we started with 5, reached at 5. So this completes one cycle. 5 goes to 6 and 6 goes to 5. So this completes a cycle. So therefore we have a 2 cycle 5 6, which is a transposition. Now we have all the numbers covered with us. So therefore what is our answer? Alpha beta. Alpha beta is, for the one cycle is 1 7 3 2, another cycle is 4 8, and the last cycle is 5 6. So the answer is 1 7 3 2, 4 8 and 5 6. In a similar manner, we can calculate beta alpha. You can calculate it yourself and check the answer here. My answer is 1732, 45 and 68. So you can clearly see the cycle alpha beta that is not equal to beta alpha. So therefore the permutations, they are not in general commutative in nature. So therefore the group which is formed by such permutations, that is a non-abelian group. So I hope you understood how we can multiply different cycles. Well, that is it for this video. Thank you for watching.